All right, welcome back to our video series for analysis of variance and design of experiments or statistical methods. So in this video, I want to go over a solution to one of the homework problems that were assigned out of the book. And I'm going to show you how I am approaching this with the file that I provided to you. So I've got the file here, and the only thing that I've changed is the header information, and by that I just mean the title, author, and date. So those are the things that you'd want to change. Again, you do not want to mess with anything here, nor in this first chunk, unless you want to take this out. If your computer is running too slow, then you can comment out this line. So if this creates a problem, all it does is makes the console down here hold more lines. But if you don't have a big memory in your computer, you may want to comment just this one line out. Leave everything else alone, please, except again down here, this turns off scientific notation. If you want it back for really large numbers, you can type in like 7, 8, 9, 10 or something, so that really small numbers are still in scientific notation for you. All right. Please don't mess with this section. This is necessary for this to knit correctly. Okay, so you definitely don't want to mess with these much with these up here. So all of this stuff is set a certain way, and is the changing of it is fairly advanced. All right, enough on that. So what I'm going to do is I'm going to run first this first chunk, and then I'm going to unminimize my screen, and then I will run the second chunk, which has all these library things, and I've told it to include false message false, and so interestingly I didn't see any messages there. Okay, now this problem that we're going to do is 226. So this is problem 2.26, and I need to take out the information here that about the Portland cement. I need to replace it with 226. So in fact, I'm going to call this, problem, I hit the wrong button, 2.26, and I'm going to call this the burn times of flares. Burn times of flares. Because I've read the question, and here's what it says. It says the following are the burning times in minutes of chemical flares of two different formulations. The design engineers are interested in both the mean and the variance of the burning times. Okay. Well, when you think logically about a flare, you usually light a flare when you're in trouble, and you'd like it to burn longer, wouldn't you? You like it to stay burning longer. So they're interested in both the length of time and the variation. So how consistent are the two burning times? So even if I give you a flare, and on average it burns longer, but the variation is so big that you can't tell the difference on some of them. Some of them burn for less time than the other formulation. Some burn a lot more. So we want it to be as consistent as possible. Okay, so what I'm going to write here is that we are testing the burn times. You can call it burning times, that's fine, but to me it seems better for burn. Burn times in minutes of chemical flares. So I'm rewording it just a little bit from two different formulations. And then I'm saying the design team is interested in whether the burn times are different and whether the variances are equal for the two formulations. Okay. Now I'm going to talk about the sample here. Now what I need to do is I'm going to put two spaces at the end of each line. I'm trying to correct my spelling, and that will cause keep the line from wrapping. Now obviously you don't really need it everywhere, but I'm going to be a little overcautious and put it everywhere, make sure it works. All right, so we have 10 observations, and I'm going to get rid of this, and I'm just going to say 10 observations from each formulation, or I can say were tested for burn times. So actually, so I'm going to put the two spaces here, and then I'm going to, I can put this back, two types, because that's what they call them, two types, formulations of chemical flares, two spaces, and then or two levels, and I'm going to put that in as an emphasis. So to do that, I put one asterisk on each side. That makes it italic. Two levels of the factor called type. Okay. And then the burn times, all I'm going to say is the burn times in minutes are entered below. Now, in this data, I don't believe we had it in the book. So what we would do is we would type it in. So I only have one thing to do here. So I'm going to go through, and since I only have, oh no, I have two of them. Whoops. Okay, so, but yeah, so I have typed it into my file in Excel. So I'm going to open that up real quick. Data, regular. And this is 226, so problem 26. Like I say, I typed this in. It wasn't in your file. So when I went to do the solutions, I saw that it wasn't in the file. So unfortunately, it doesn't help you, but the next class that I teach in this will have it in their file for them. And so what I'm going to do is I'm going to add the order, which is these are in the order that they were produced. So that's usually the case. Not always, but usually the case is the data is in that. Now notice something that I'm doing here. I'm going back and then down. If I go down and over, look, it doesn't take me to the right spot. But if I come from here and go straight down with the arrow, it takes me to where I need to be. 9, 10. Now, comma, I can come up to the top here, comma, 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 comma. Ooh, too far. Now, so just, oops, just a space. I like to line things up. Oops. And you need to make sure that there are commas in between everything. And then not on the last line, but commas everywhere else. Okay? Not on the last line, because that's going to be right before the parenthesis. And you don't need a comma before the parenthesis, or else it thinks that there's something else. So I need to change my column names. I'm going to leave it as ID or order. I think did I call it order? Yeah. And then I'm going to call this type 1, no space. You don't want spaces in your variable names, or else you have to go through some quite some gymnastics code-wise to reference them. So we don't want to do that. Now I need to change this table. By the way, I found out that when you knit it, it puts the table number automatically, so we want to take the table numbers out. Sorry about that. And so what we can do up here is just say table 1. Give ourselves a note so that if we need to, we can see what we have. Okay, so I'm going to call this chemical flare data, burn times in minutes. So chemical flare data, burn times in minutes. Oops. So, and then that's all I need to change there. Now I'm going to run this. Okay, so it sees that I see that it printed everything out nicely. And now I need to look at the problem. The problem says test the hypothesis that the two variances are equal. That's A. So so I will leave. So descriptive statistics, they're optional because they're not. It's not requested for this homework. But I'm going to take it out because it wasn't asked for. Okay. Now let's see. Do I need it anywhere else? I can't remember if I need it somewhere else. If I need it somewhere else, I don't think I do. No, I don't see where I need it. If I needed it somewhere else, I'd leave it in here so that I could use it. Okay. So since it's not requested, I'm just going to take it out. Okay. I can come all the way. And if I were going to leave it in here, well, let's say I do leave it in here. That's what I did in the homework and the solutions I posted. And I say this is optional for this homework problem, but not for projects. So that was my note to you all. And so now we're going to say this. So I'm going to say the summary statistics are contained in table 2 below. You don't even need below, just table 2 is fine. We see that the mean. Okay, so before we can do this, we need to run it. Now, I'm going to get rid of the ones, all this commented stuff that I'm not using. I decided not to use any of those, so I'm just going to keep what I'm using. So I give you a lot of options in some cases. So you just want to leave what you actually used. You know, otherwise you're cluttering up your code and you're making it longer and more difficult for you and anyone else to read. So I'm going to call this chemical flare data, burn time, minutes. Chemical flare data, burn time, minutes. Okay, so that should work. And then I run this, and then I can look at it. And what I see when I look at this is that the mean burn time is 70.4 versus 70.2. I hope that's what I said. What am I comparing? I compared Q1 by mistake. Okay, so I looked at the wrong thing. So let's get rid of all this and correct this. So we have that the mean burn time for formulation for type 1, is higher slightly higher, I'm going to say. And here I'm going to put parentheses, and then I'm going to say 70.4 minutes. 70.4 minutes compared to type 2, and that'll be 70.2 minutes. And then, however, the median burn time, so I'm looking at this table and I look at the median, so even though the mean is higher than for 1 and 2, but the median is lower, 68.5. Oops, don't want to do that. The median burn time for type 1, 68.5 minutes. Is lower than that of type 2. And we'll say, what is that? That is 70.0. Okay. All right. The standard deviation, oh yeah. So the standard deviation for type 1 flares is 9.26 minutes, same units, and is slightly smaller than the standard deviation for type 2, which is 9.3. Yeah. 9.37. Minutes. So now I see that instead of putting these, I just put the dollar signs so they're in the same font here. Okay, so now, oh, and I can get rid of this too. I don't need anything that was really commented out to be submitting. Okay, so we're going to remove, the next thing that's asked is the test for equality of variance. So I'm going to remove the histogram, and I'm not going to remove the QQ plot. So basic graphs, let's see, dot plot, okay. So I need to make sure that I'm only getting rid of that. And then strip charts. Okay. Okay, so I want the equality for variance next. So what I'm going to do is I'm going to take this QQ plot and I'm going to, I just cut it and I'm going to paste it below here before the two-sample t-test. Okay, so actually, undo that. I'm going to put it after the two-sample t-test. and then I'm going to get rid of everything else because I don't need it. So I'm going to come back up and I'm going to do part A. So right here I'm going to put part A, test for equality of variance. And then we perform, I'm only going to do one of these. And I'm going to choose Levine's because most of the time, because it's the most robust against mild departures from normality. So we perform Levine's test for the equality of variance since it is robust against moderate departures from normality, while Bartlett's test and the F-test are not. Okay. Then I'm going to put my hypothesis statement. I've got H naught sigma 1 squared equals sigma 2 squared. That's what I want. Versus sigma 1 squared is not equal to sigma 2 squared in the model. Yij equals mu I plus epsilon ij, the means model, and that's fine. I equals 1 to 2 and j equals 1 to 10. We do have 10. There are 10 observations we can see, so that didn't need to change. I still have I equals 1 and 2. This is a 2 sample thing, and then I have 10 in each. So that can stay the same, and by default we're going to use 0.05 unless they tell us not to. So this statement is fine. So now I don't need the test statistics for Bartlett's test or the F-test. So what I'm going to do is I need to come down here and change this to be type, burn time and type. Now I don't remember us melting the data, so there has to be, okay, so here's the data melt for the descriptive statistics, and I needed to change this to, see, I need to change this to burn time, and then this will be, instead of treatment, I'm going to say type, and then this becomes burn time. So that when I melt the data, it's going to be okay. And then I have to say here, I have to change this to burn time by type. So my right now it says treatment type 1 and type 2. That's good, but I could leave it that way. But I don't like the fact that underneath it, it's saying strength instead of burn time, even though I don't have it printed out anywhere. I know that it's that, and I need to correct that for myself. Okay, just to be proper. Now, of course, that worked. And then I've got burn time by type, and it is telling me that burn time is not found. BURN. Because I did this, but in my data, so I need to make sure that everything is capitalized correctly. So there. If I don't have the right capitalization, it doesn't know what to do. So there we go. So now everything is type 1, type 2. Okay. And so now when I do this, Bartlett's test I don't need. I need Levine's test. And I'm going to do burn time, capital T, by type. Okay. and data equals y 0. I don't need the var test, that's the f test here. So I'm just going to do that. And so I run this, and I need to, let's see, so Levine test. So what did I do? Okay. So the test statistic, trying to remember how I got the test statistic for Levine's test. Did this? Oh, the F value is right here. And it threw me off because it's 0. Now, we can't put 0 in here. So I'm going to put less than, F is less than 0.001. You don't want to put 0 there. And then we have 1 and 18 degrees of freedom. So I was looking for the F value, but 0 threw me off. And look, I've got a p-value of 1. We never put 0 for an F, and it can't get there. And we never put 1 for the p-value. It can't get there. So this will be a p-value that's greater than 0.9999. Okay? So please don't use 0 for F or 1 for a probability. So we can say it's greater than 0.9999, less than 0.0001. Okay, so we failed to reject H naught. Let's see. So we failed to reject H naught. Hence, there does not exist sufficient evidence to support the claim that the variances are different between the two types of chemical flares at a 95% confidence level. Okay, so I need to take out this last sentence. Using N1 equals N2, so I needed to add that. So, comma, using N1 equals N2 equals N equals 10 observations. Okay, so we should always have that, the sample size. So to do an underscore, to do a subscript, I do an underscore, N underscore 1. And I can say equals N underscore 2. I could have just said N equals 10 observations per, from each type, I should say, from each type. There we go. And then it's very clear. If you just say N equals 10, but it's from each type. Okay. So that is part A. So let's go to part B. Okay. So part B is a two-sample t-test. So I'm going to put part B, period. Two-sample t-test. And here I need to talk about, since the variances are not significantly different according to Levine's test in part A above, we will perform the two-sample t-test under the assumption of equal variances. Okay, so we need to talk about, when we're going to do the two-sample t-test, we need to talk about what's our decision concerning the variances. Are they equal or are they not? And so now I have mu1 minus mu2 is equal to 0 versus mu1 minus mu2 is not equal to 0. In the model, I is still equal to 1 or 2, and j is from 1 to 10. I didn't need to change that at alpha equals 0.05. So unless the problem specifies something different, we don't change it. Okay, so here I need to change my code. Y1, I need type 1. And here I need type 2. Two-sided. Variances are equal equals true. Variance equal equals true. So yes, we're going to do that. And we can get rid of that so that we're just putting what we need to in the code. So we run this and we get a t value of 0.048. So I'm going to say t equals 0.048. And that I could put it to 4 decimal places. There's a 0. With degrees of freedom, it's going to be 18 because that didn't change. And a p-value of 0.9622. 9622. Hence, now we fail to reject H naught. We conclude that there does not exists sufficient evidence to support the claim that now the burn time, okay, between type 1 and type 2 formulations are different at a 95% confidence level. The test was conducted using a random sample of N1 equals N2 observations from each type. You'd say formulation, but I'm calling it type, so I'm going to use that. Okay. And now, the next thing that they ask us to do is they don't ask us for a confidence interval, right? So 226, they simply say, use the results of A, test the hypothesis that the mean burning times are equal. So part B, use the results of part A. That was testing whether or not the variances were equal or not. Okay, so we did that. We used that the variances are equal, the results from part A. And then we tested it, and it said use alpha equals 0.05. What's the p-value? We have put the p-value in here. So you can write this up in this format, and you're answering the question, but you're also doing a good analysis. Don't just answer the question. Write up the analysis, okay? So if it says to do a 2-sample t-test, do the 2-sample t-test, do all parts of it. And it asks for the p-value, that's going to be part of the answer. So you don't have to do anything special there. All right. And then part C is going to be, so let's see, do I use 1 or 2? I use 1. Part C, normality. Okay. And unfortunately, in the solutions I provided, I didn't do this right. So now, let's see what it says. It says, discuss the role of the normality assumption in this problem. Then check the assumption of normality for both types of flares. Okay, so checking the normality means we're going to use a QQ test, or QQ plots. Okay, so the assumption of normality is required for the test of equality of variances. Okay, so for the test for equality of variances. So any indications of non-normality, especially outliers, can have a significant impact on or significant effect of the variance test. So any indications of non-normality, especially outliers, can have a significant impact or effect on the results of the variance test. Okay, test. So, but that's on the variance test. Now let's talk about the assumption of normality, and I'm gonna come up here and do 2 lines. Okay. Let's make sure we have our spaces at the end of everything. So, although I have V space, it's not as important. But here it certainly is. Or else, well, there we go. Okay. So that was part C, normality. But we've talked about the variance test. Now let's talk about the 2-sample t-test. The assumption of normality is required for the t-test However, the effect of small to moderate departures from normality has only a small effect on the results of the t-test. So, assumption of normality is required for the t-test. However, the effect of small to moderate departures from normality has only a small effect on the results of the t-test. Okay, so it's not as important, but it's important, but it's not as important. Okay, so one outlier may not affect it too much. Okay, so now I'm going to do tests for normality. QQ plots. And whether you use capital Q or little q is a preference, that's fine. Okay, so to do this, I need to change this to burn time, B-U-R-N, capital T-I-M-E, type, T-Y-P-E, capital T, okay? And I can run this, and now I take a look at these, and interestingly, that it identified 5, but look at this point out here that's further away. So when I look at this, the thing that bothers me a little bit is this curve right here in the middle, where these points are floating away from the line in the center. That shouldn't happen. Over here for type 2, the normality assumption is a lot better. These points float around this line a lot better. Here, they usually don't float off to the above the line. They usually float below the line, and we have these 2 points here that are further away from the line in the middle than I would like, but it's still not outside of the confidence level. Okay, and this point is not outside of the confidence level. It's at the tail, though. It's at the extreme values, and so it's not very significant to me at all. I'm more concerned about these points here in the middle. Okay, so I hope that helps you understand what to look for in there. Now, the thing is, we didn't cover a formal test for normality. There are some tests. The Shapiro-Wilks test is the most common and probably the most robust test to use, highest power and that sort of thing. But any outlier will make it reject the null hypothesis. So it's really preferred to use these QQ plots to test for normality. We have a lot more interpretation and than just this hardcore test that says, yep, it is or it isn't. And so, all right. So for type 1 flares, so I'm gonna, for type 1 flares, there are a couple of points near the middle of the graph that are away from the line, but not outside the 95%, 95 %, $, confidence bands. Okay. There is one observation, so I'm telling what I see. There's one observation at the top of the graph that is further away from the line. But we expect a poorer fit for the more extreme observations. When we have a small sample size, which we do. We have sample size of 10 each, okay? Small sample sizes. Okay, in conclusion, there are not any points outside the 95% confidence band, outside of, the 95% confidence bands, outside of the 95% confidence bands, and the observations generally fall near the theoretical quantiles. What do I mean by that? Well, here's the theoretical quantiles, and so the points here, the line here is where the theoretical quantile and the actual time should be. So for the most part, these points fall near the values, the percentiles for the burn time, or the values for the burn times fall near the quantiles, the theoretical quantiles for that burn time. Here in the middle, they're a little further away, but I've already noted that. Okay, but in general, they do. Hence, there's no indication that the data for type 1, and I can put this, yeah, I think I'm gonna, is flares, has significantly departed from a normal distribution. Okay, now why did I say so much for this one? Because I saw some irregularities, and if you see irregularities, you want to point them out. So I talked about what I saw that may have been of concern. Thankfully, we have those 95% confidence bands on there, so we can tell if they're outside of it or not. Without them, it's a lot more difficult, and it seems a lot more subjunctive, or subjective, not subjunctive. So now, for type 2 flares, so this test, in the book, they ask for check the assumptions of normality for both types of flares. So we need to talk about each type of flare separately here because they ask for both of them unless they're both really similar and we don't need to say anything except they're good. Okay. Now for this type 2, I don't have any issues with that. The values are close to the line, some are above, mostly are below, which is a little concerning, but very close, and some are above. So we have, out of 10, we have 3 that are above, the first one at the bottom and the last 2, or next to last 2 at the top. And then the rest are below, but they're very close to the line, so there's no issue here. So, so I'm going to say, and let's italicize this, okay? And I can say, I can actually copy if it's faster. I don't know that it was. For type 2 flares, all points fall close to the line, to the QQ line. And no points are near or beyond the 95% confidence bands. Okay. Hence, there is no indication that the data, I'm going to copy and paste and then change it for type 2 flares, has significantly departed from normality, from a normal distribution. Okay. And so I went through on the homework solution, I showed you how to do a Shapiro-Wilks test. I gave you the code for it, but these tests are very, very sensitive to outliers or any departure from normality. So I don't recommend that you use those as a general rule. These QQ plots are what we should use. Now, to knit this, I come up here and I say knit to PDF, and let's see if I've made any mistakes, because if I've made any mistakes, it's not going to do it. You see that it goes to the R markdown and it goes through stuff, and then it's got this output file, and hey, it popped up, so I didn't make any mistakes. If you did make a mistake, let me make a mistake and show you what can happen. Let's, I'll take that out, the backslash. Let's see if it causes a mistake when I knit now. Sometimes they can be very simple things that causes it to halt execution. I think it's going to actually go ahead and do it, but it won't look like it should. Okay, so even though I didn't put the backslash, it's just not going to show anything. It's going to think that this is a comment. In LaTeX, this % sign is their comment. And here in R, a £sign is our comment, right? If I hit a £sign here, I comment out that, okay? So LaTeX, it's a % sign. So anytime you want to use a % sign to actually do something, you have to, I think, oh, here it is. You have to put that backslash or else the % sign won't cancel out. It just thinks that what's after that is comment and don't print it, okay? So what if I left off one of the $signs? That's a common thing that happens. We think we've typed it and we haven't. And if this knits to a PDF, I'm going to be very surprised. It did. That's interesting. Okay. So, wow. I'm like I said, I'm very shocked that that did that. How about if I leave off the first one? I just want to show you that it gives you some information. Nope, it looks like it's going to do it. Yep, all right. So, how about if I do 2 of them by mistake, but not the second one? Well, I'm not going to spend more of your time. It looks like some minor mistakes are getting through okay. which actually kind of shocks me that it's doing that. It has given me errors many times for these things. But so once you knit this to PDF, if there was something wrong, it would tell you down here. It would say red halt execution, and it would give you some lines that you could go back and look at. So once you've done this, take a look through it, see that everything's going where you want it to go. One of the things that you can do is you can put in a new page if you don't like how your data is going. So here I have the two tables together, which is fine to me, even though I didn't really want them crammed up together. I'd rather have the table down here with descriptive statistics, but that's one of the things about LaTeX. There is a way to do it, but it's a pain. So one of the things that you can do is put new page in here. So we could put, let's see, I may have already, for descriptive statistics. Where is it? There it is. Yeah, I've already put new page. And it's still, so the only other thing to do would be, let's see, new page, and see how that knits. Now, you can have it open in this PDF viewer, and it will still override it. But if you have it open in regular PDF, it will not. It will crash because it's open. So let's see if it changed anything. Okay, so by putting the new page after that, it not only doesn't put it with table 1, it moved it all the way to page 3. So that's just something that and you notice that it didn't put this on a new page, it put it on the same page with table 1. So again, there is a way to do it to make it go exactly where you want it to go, but that's an advanced topic, and I didn't want to clutter up the PDF file with that. But I hope this video has helped you understand what we're doing with the homework. We're answering the questions. We need to answer them in the order that they are asked, okay, in the homework. And make sure you do answer at least what they've asked. If they ask you to do a test, a hypothesis test, you need to do the whole hypothesis test, all the parts, put it there, including the conclusion sentence, which I have given you for that. Same thing with a confidence interval. If it asks you for a confidence interval, you need to put that conclusion. We are blank % confident that the interval, and put it in there, contains the true population parameter, whatever that is, and describe it, you know, what for, the true mean burn time for the type 1 flares, let's say, if that's what we're doing. The analysis was performed using a simple random sample of n equals 10 observations, okay? So make sure that you put what I'm asking for in there, but I hope this helps. You just need to answer, for the homework, answer what's been asked. For the project, you want to do all of the analysis that are necessary, okay? And so again, that's long enough for this. Talk to you next time.